Here is to change it to exponential form. Since it's already equal to x, we can go ahead and say 100 is equal to 10 to the x power. At this point, you could either do it one of two ways. The first one is to make them equivalent bases. So 10 to the second power is equal to 10 to the x. Since they both have the same base, then you could just say their exponents are equal. You have 2 equals x. The second way you could do this is you could just take the natural log, or you could take ln of both, or you could take log of both sides. Ln just has a base of e. Whoops, that should be natural log of 10 to the x. What this does is it helps us to move the x to the front, so we can just rewrite this as ln of 100, and then we have x ln of 10. And then here we can go ahead and isolate x by dividing by ln 10 on both sides. And we could put this in our calculator, and you should get x is equal to 2. So again, these are two different ways you could do the same problem. These are two different ways you can do the same problem. The next one, we can do log of 2. This was on the homework a couple of days ago. Okay, does anyone still need the top problem? I'm going to scoot it up a little bit. Okay, so in this second problem, the first thing you would do again is to write it in an exponential form. So you move the 2 over here. It would be 7 root 7 of 32 is equal to 2 to the x power. So just as a reminder that whenever you take the root of something, how many you need is going to be indicated by a fraction. So as an example, 32 to the 1/7 is the same as 32 root 7. Okay. So again, right now what we're trying to do is we're trying to transform this so that they have the same base. So the next step is, you should know that 32 is a factor of 2. So it would be 2 to the 5th power, which is equivalent to 32. So what we know is that by property of exponents, that if you're raising a power to another power, you're actually going to multiply it. So if you're raising a power to another power, so we're raising 2 to the 5th power, and we're raising it to the 1/7 power, we're actually going to multiply them. So it's going to be 2 to the 5/7 power is equal to 2 to the x power. So now that we have two numbers with the same base, the exponents likely should be equal because both sides are equal. So x is just equal to 5/7. The second way we can do this is that when we get to, let's say that we get to this point right here, or I'm actually going to start right here, is that we can take the natural log of this. So we can take the natural log of both sides. We could take log 32 to the 1/7 is equal to log 2 to the x. And again, natural log and log are exactly the same. The only difference is that log is using base 10 and ln is taking log base e. Okay, log base e is with the base of e. Oh. Skip this over. Okay, so the reason we do this is so now we can move the 1/7 to the front. 1/7 log 32 equals x log 2, and now we can isolate x. We can isolate x by dividing both sides by log base log 2, and now we should get x is equal to, and you could type this in your calculator. You can go ahead in your calculator and you can type parentheses 1 divided by 7 log 32 divided by log 2, and actually in my mode, if you go to mode right here on top, you can go ahead and change, if you scroll down, you can change it so that your answer can be defined in fractions. I'm going to go ahead and click fractions here. Just do second quit, and then you can do your answer. And you can see here, my answer is 5/7, which is exactly the same answer as the other method that I used to solve. So you can see here again that I'm just showing you two different methods you could use to solve these problems. Both of these are valid, and there is no difference in either one of the answers. Okay, does anyone still need this? If you do need this, can you show with your fingers how much time you need? Okay, take that as a no. One more time. Okay, so that's just all review of what we did last Thursday and Friday. So if you missed anything about Thursday and Friday, that's exactly what we did last week. That's exactly what we did last week. So today's problem is a little bit different because now we're going to use what we haven't really touched yet, but this is what you wrote down last week. Adjust this. So you have log base 5 of 3 of x plus 3 log base 5, 2 equals 3. So again, you have log base 5, 3 of x plus 3 log 5, 2 equals 3. So your first step that you could do is you can remember that this 3 can be brought to this x, could be the exponent for 2. So we're actually going to raise 2 to the third power. Okay. So this 3 that's in front of log base 5 of 2, we're going to actually raise this 2 to the third power. Let me go ahead and rewrite it as log base 5, 3 of x, plus log of 5, 2 to the third power is equal to 3. And then I'm going to go ahead and actually expand that out. So this is going to be log base 5 of 8 equals 3. You can combine any two things which have the same log base. Just as a reminder that if they're being added together, then you're going to multiply the two different values together. So in this case, since we have both log base 5, this is going to be log base 5, then we're going to multiply 3x and 8. We're going to multiply 3x and 8. And I'm just going to go ahead and rewrite it just so you know what I'm doing here. I'm doing 3x times 8. Again, this is a rule of logarithms. And then I'm going to rewrite this as log base 5 of 24x is equal to 3. Okay. So at this point, it should look very familiar because now we want to change it to exponential form. Okay, so previously we didn't really use the properties of logarithms, but now we can use them, and now we can move this so it's exponential form. We have 24x is equal to 5 to the third. I am just going to go ahead and write this extra step. You don't necessarily have to. 5 to the third is 5 times 5 times 5, which is 25 times 5, which is equal to 125. And then you could just divide by 24 on both sides. You get x is equal to 125 divided by 24. And that's your answer. That's your answer right there. Not a very satisfying answer, but it is your answer nonetheless. Okay, any questions on this one? Okay, does anyone need more time on this? I see some people need more time. Okay, no one needs more time on this one? Okay, so our last example, so the last example I will give you before you can start working on your own. And this one is probably a combination of some other chapters we've done, is log base 4 x squared minus 1 minus log base 4 3 of x plus 3 equals 1. Wow. So again, this is a combination of two chapters that we've done, and we will kind of explore why. Okay, so for this one, I want you to think about what we did previously, where we had two logs with the same base, and we added those together, and so what we did is we multiplied the two terms together. So in this case, we're subtracting two logs with the same base, so likely you would do the opposite of adding. So when you add, you multiply. And so when you subtract, you should think that you're going to divide, right? You're going to divide. So we're going to go ahead and rewrite this as log base 4 x squared minus 1 divided by 3x plus 3 is equal to 1. So again, the rule of thumb here, and this is something that you've written down in your notes, is that if you're subtracting two logs with the same base, by the properties of logarithms of subtraction, you're going to divide x squared minus 1 divided by 3x plus 3. So the one you're subtracting, you're going to divide the first amount by. Okay, so this problem should look very familiar at this point, even though it looks a little bit crazier. The first thing that you want to do is you want to change this to exponential form. So you're going to move the 4 to this side. It's going to be x squared minus 1 divided by 3x plus 3 is equal to 4 to the first power. Okay. So just like before, we're just going to raise it to exponential form. The next thing we want to do is we want to get rid of, we're going to solve for x, but to solve for x, we need to get rid of x on the bottom. So we're going to multiply both sides by 3x plus 3. Just as a reminder, if that you're multiplying by a plus or minus, then you're going to have to multiply everything by that. So this is going to be 12x plus 12. These are just going to cancel out, so it's just going to be x squared minus 1 the last thing you would do is, well, to solve for something where it has a exponent to the second power, is you need to move everything to one side and then factor everything out. So again, if it's to the second power and it has 3 terms, you want to go ahead and move everything to one side. So we have x squared minus 12x minus 13 equals 0. And this problem should look very familiar at this point, because now you should automatically think, okay, I'm going to factor this out. I'm going to factor this out. Okay. So again, what we did is we moved this to exponential form. After moving to exponential form, we need to solve for x, but before we can solve for x, we need to get rid of x on the bottom. So you can see here, we got rid of x on the bottom, so we had to subtract 3x plus 3 from both sides. And then what we did is that we canceled out 3x plus 3 on the left-hand side. On the right-hand side, you can see we did 4 times 3x, which is 12x, 4 times 3, which is 12. And then we moved everything to one side so we could factor it out. And so if this is familiar, hopefully it is, we have the diamond method, negative 13, negative 12. So you want to think about two numbers that when multiplied equals negative 13, and when added together equals negative 12.
Negative 13 and 1.
Right, negative 13 and positive 1. So when you multiply them together, they equal negative 13. And when you add them together, they equal negative 12. So your answer, or at least you could change this to x minus 13, x plus 1 equals 0. So we're almost done, actually. So if we solve for this, we could do x minus 13 equals 0, x plus 1 equals 0, and then we could add 13 on both sides. We get x is equal to 13, and then we subtract 1 on both sides. We get x equals negative 1. Okay, so actually at this point we're almost done. And you might think, oh, you have your answers already. Why wouldn't we be done? So one thing we have to check here, and something you might want to star, is that you cannot take the log, you cannot take the log ln of 0 or negative numbers. So you cannot take the natural log or ln or log of 0 or negative numbers. Okay, so what I'm going to do is I'm actually going to check both of my answers. For the first one, I'm just going to go ahead and plug it in and kind of take it at face value. So my answers are 13 and negative 1. So I'm going to plug this back into the original equation. So log 4 of 13 squared minus 1 minus log 4 3 times 13 plus 3 equals 1. So if I plug this back into my original equation, you can see here that, okay, if I look at the logs, well, this is going to be a really big positive number. This is also going to be a really big positive number. Am I going to take a log of a negative or 0? No. So I would say, okay, 13 checks out, right? 13 checks out. That's good. So it's good. So I don't need to solve all the way through. I just need to kind of eye it, look at it, and see, does that answer work? Is it still going to be a positive number that I'm going to take the logarithm of? And since it is true, it's going to be a positive number, some positive number, then I'm okay with it. I'm happy with it. However, when I take the log 4 of, let's see, negative 1 squared minus 1 minus log 4 of 3 times negative 1 plus 3, you can see here, oh, okay, looks like some things are going to cancel out. Let me just do it one more step further. 1 minus 1 minus log 4 of negative 3 plus 3 equals 1. So then we get log 4 of 0 minus log 4 of 0 equals 1. Or technically log 4 of 0 divided by 0 equals 1. And you can see here that when we divide by 0, or even when we're taking the log of 0, it doesn't make any sense. It doesn't make any sense. So if we look at the previous line right here, it says log 4 of 0. If you guys remember, when you take the log of a number, so log base 4 of 0, what it's asking us is what exponent would you raise 4 to get 0? What exponent would you raise 4 to get 0? And in this case, there is no number that we can raise 4 to get 0. Okay. So in this case, it does not check out since we cannot take the log of a 0 So negative 1 does not work. Okay, so your only answer here would be 13. 13 would be your only answer. So 13 is your only answer for this one. 13 is your only answer for this.